Welcome to HB Tuner's Ford Gen 2 Coyote Training Part 20. This training module, we're going to be taking a look at dialing in our low and high slope injector tuning if we have our fuel trims all out of whack and we know that our mass airflow sensor is registering and reading properly. So the MAF curve is dialed in and we're seeing a large discrepancy in our fuel trims. What do we do to resolve it? We don't want to bake bad injector data into our MAF curve. Well, we can correct this using our low-high slope tuning technique that I'm going to be outlining here in the tutorial. We're going to be looking at our Excel spreadsheet calculator and our VCM scanner to fix the issue. So we're going to go through the process from start to finish so you can see what everything's going to look like if you're in the situation where you have bad injector data. Without further wait, let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at how to do our low and high slope injector tuning if we have bad injector data. Let's say we change our injectors out from stock or putting in aftermarket injectors. We know that, let's say, our mass airflow calibration curve is valid. Either we're using a MAF curve from the Excel spreadsheet that I provided here under our MAF area, or we've used the MAF calculation function, and we know that that's accurate. We can trust it. Maybe even went through and drove the vehicle with the air intake assembly and the stock injectors just to make sure that everything was in line, and then you've changed your injectors out. And now you're finding that it's rich or lean and there's an error there. Now we know we don't want to absorb any bad data into our MAF curve. That leads to a cascading effect throughout the calibration file, torque table, spark timing, variable cam control, idle control, all get affected by having bad math data. We want to make sure that that data is as accurate as possible. So if we're finding that after we fire off the engine, we put all the injector data in, put all the new fuel system components in, and it's rich or lean, what do? Well, we can actually dial in and tune out our injector data. So I'm going to show how we can do that to the low and high slope here in this tutorial. We're going to be working in the VCM scanner in some specific histograms, and we're also going to be taking a look at using our Excel spreadsheet. I have a calculator specific for working with our injector slopes and how we can actually edit them individually, low and high slope, to clean up any discrepancies or deviations in our fuel delivery so we do not absorb a fueling error into our air mass representation. Again, I've talked about this in many other tutorials. We have that underlying equation, fuel mass is equal to air mass divided by target air fuel. When we're dealing with registering our air mass, if that's accurate, we bring in a certain amount of air mass to the engine, we divide it by a certain target air fuel that we're requesting from our commanded lambda tables. That gives us a fuel mass of what we should put into the engine. That fuel mass gets converted into an injector pulse with knowing low and high slope, breakpoint multiplier, and offset values that characterizes the injector's behavior, and we turn that fuel mass in grams per second into an injector pulse width. And if everything is right in our modeling between the air mass modeling, so we're registering the correct amount of air mass the engine is ingesting, and our injector data is able to convert the fuel mass into an injector pulse width properly, we'll find what we're left with is we're hitting that target air fuel, target lambda spot on, and our closed loop correction, our short and long-term trims, have to do minimal amount of work because our air and fuel model is nailed down, and that's what we want. So we don't want to take bad injector data that doesn't allow us to convert a fuel mass request into an injector pulse width correctly, and we have a rich or lean condition. We don't want to bake that into our MAF curve. We want to avoid that. We talked about what to look for in the last tutorial, spotting trends in our MAF calibration after we've dialed the MAF curve and making sure that we don't have unrealistic MAF values that are populated so that we're not underestimating the amount of air mass. We have those marker points we looked at, we talked about. This video is going to now help you sort out how to fix a fuel error problem. It's very common to put injector data in and not get the correct fueling when you're running those larger injectors because most manufacturers can't provide you the injector data correctly. Ford Racing is pretty good. Injector Dynamics is pretty good. FIC is hit or miss. DW is hit or miss in terms of the injector data. Now, I have supplied injector data in our template applicator, and we talked about that earlier in training modules. That injector data is coming right from the manufacturer. So I'm not personally making up that data. That's coming right from their data sheets. I simply transcribe that data into the template applicator files that you can then use for tuning and going in and populating all your tables. But if you have a fueling error, you need to fix it. Regardless of using my template applicator or entering the data in manually from an injector manufacturer, there's a problem. You don't want to bake that into the MAF curve, and this is going to show you how to not do that. So let's jump in here.
This calibration file is the same one we were working with in the last tutorial. I've labeled this low-high slope tuning just so I have a different name for this tutorial. I want to go and point something out real quick. The last tutorial, I changed the low and high slope just to illustrate bad injector data. It wasn't enough of a change to really disturb our fuel delivery. What I'm going to do right now is really drastically change this. Now, just to quickly go over how this works, the low and high slopes translate the fuel flow rate request into an injector pulse width. That's known as our base pulse width. The low slope specifically translates the nonlinear behavior of the injector. Once we hit this break point, the break point's the separation between a low and high slope. The high slope is when the injector goes linear. And the high slope value then would be representing that linear operation. So we have these two different flow ratios. That essentially represents the slope line, which we'll look at here in a little bit on our Excel spreadsheet in a graphical illustration. Again, this is all covered in the injector tutorial, but just to go over.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.